Now I am starting a new chapter, three-dimensional geometry. In this chapter, first topic is direction cosines. Direction cosines and direction ratios of a line in the space. Direction cosines and direction ratios of a line in the space. Say in the previous chapter we discussed about direction cosines and direction ratios of a vector in space. Now line in the space. Say words are similar. In the space, every time we consider coordinate axis, x axis, y axis and z axis. Now if there is a line in this space, as for example, suppose this is a line, here I am taking a line, this line is L. L is passing from origin, and when we draw a picture of line, we show direction on both sides. So if we consider this line directed in this direction, then we say that this line is making angle alpha with positive direction of x-axis. It is making angle beta with positive direction of y-axis and making angle gamma with a positive direction of z-axis. Then alpha, beta, gamma are said to be direction angles and their cosine values are direction cosines. So see, if a line passing through origin making angles alpha, beta and gamma with positive directions of x, y and z axis respectively, then alpha, beta, gamma are said to be direction angles of that line and their cosine values, and cosine values, that is cos alpha, cos beta and cos gamma. Cos alpha, cos beta and cos gamma are said to be direction cosines of this line. Now see, line, whenever we draw a line, we take arrow on both sides. In considering direction angles, we have considered this direction. We have considered this direction as direction of this line. But if we consider this direction as direction of line, means this is a directed line. Direction can be shown by two methods, two ways, either on this side or on this side. So if we consider this direction as a direction of this line, then we can say that this is also making angle pi minus alpha. Take supplementary angles. Here this is alpha, so this will be pi minus alpha. Similarly, this is beta. This line is making angle beta with y-axis. So this side there will be pi minus beta, and similarly pi minus gamma. So here pi minus alpha, pi minus beta and pi minus gamma can also be taken as direction angles. If direction of line is reversed, then pi minus alpha, pi minus beta and pi minus gamma can also be taken as direction angles, and their cosine values cos pi minus alpha, cos pi minus beta and cos pi minus gamma will be their direction cosines in this case. So we can say that every line has two set of direction cosines. So every line has two set of direction cosines. Every line has two sets of direction cosines or direction angles. Now if line is not passing from origin, suppose this line is not passing from origin, this is suppose L dash, this line is L, this line is L dash. If any line is not passing through origin, then to find direction angles and direction cosines, consider this line. Take a line, imagine a line which is parallel to a line L dash and passing through origin. Say this line is not passing from origin. So consider a line which is passing through origin and parallel to that line. So this is the line passing through origin parallel to this line. So whatever are direction angles and direction cosines of line passing through origin, same will be for this line. So if any line L dash which is not passing from origin, passing through origin, if any line L dash which is not passing through origin, then direction angles and direction cosines of L dash equal to direction or will be same as direction angles and direction cosines of L, where L is passing through origin and parallel to L dash. So this is the method when line is not passing through origin, how to find direction cosines. So it will be same as direction cosines of line L. So every line has two set of direction cosines. See, direction cosines, if L, M and N are direction cosines of any line, if L, M, N are direction cosines of any line, then sum of square of these numbers is always 1. That we discussed in previous chapter. If L, M, N are direction cosines of any vector, then sum of square of that three numbers is always 1. Now if A, B and C are three real numbers, any three real numbers such that A is equal to KL, B is equal to K into M, C equal to K into N. That means A, B, C are proportional to direction cosines. Three numbers which are proportional to direction cosines of line, then these three numbers A, B and C are said to be direction ratios, of that line. So if A, B, C are three numbers such that A, B, C are proportional to direction cosines, then A, B, C are said to be direction ratios of that line, whose direction cosines are L, M, N. Now see, if A, B and C are direction ratios of any line, then its direction cosines are plus minus A upon root A square plus B square plus C square, comma, plus minus B upon root A square plus B square plus C square, comma, plus minus C upon root A square plus B square plus C square. From direction ratios we can find direction cosines. Say this is L, this value is L, this value is N, and this is N, and sum of square of these three numbers is 1. And say here we are getting two sets of direction cosines. So these are two sets of direction cosines of that line. So from angle, this is the method to find direction cosines. Now if a line is passing from two distinct points, say as for example in the space x-axis, y-axis and z-axis, Suppose this line is passing from two distinct points x1 y1 z1 x2 y2 z2. If any line is passing from two distinct points x1 y1 z1 and x2 y2 z2, then method to find direction cosines. How to find direction cosines if two distinct points are given? So method is, first of all, find distance AB. Distance AB is square root of x1 minus x2 square plus y1 minus y2 square plus z1 minus z2 square. This is distance. Distance is AB. And say here direction cosines are, direction ratios of line AB are, direction ratios are x2 minus x1 comma y2 minus y1 and z2 minus z1. We can change sign. We can say direction ratios are x1 minus x2 y1 minus y2 and z1 minus z2. This can also be taken. Direction ratios if two points are given. So these are direction ratios of line. So direction cosines, therefore direction cosines of line AB is, what we do, if direction ratios are given, then we divide these numbers by square root of a square plus b square plus c square. That means square root of sum of square of these numbers. It is nothing but distance AB. So if these are A, B, C, this is a square plus b square plus c square. Square root of a square plus b square plus c square, it is nothing but distance AB. So direction cosines of line AB are x2 minus x1 upon distance AB, comma y2 minus y1 upon distance AB and z2 minus z1 upon distance AB. Or you can also take x1 minus x2 upon AB, comma y1 minus y2 upon AB and z1 minus z2 upon AB. Every line has two sets of direction cosines. Now question, if a line makes angles 90 degree, 135 degree, 45 degree with the x, y and z axis respectively, find its direction cosines. Say here direction angles are given. Direction angles 90 degree, 135 degree and 45 degree. These are direction angles. So direction cosines are, therefore direction cosines are their cosine values: cos 90 degree, comma cos 135 degree, comma cos 45 degree. That is cos 90 is 0, comma cos 135, so 90 plus 45, second quadrant, in second quadrant cos is negative, so minus sine 90 degree, say cos 135 degree, so 90 plus 45, so this is minus sine 45, so minus 1 by root 2. So cos 135 is minus 1 by root 2, comma cos 45 degree is 1 by root 2. So these are direction cosines. Now second question. If a line has direction ratios minus 18, 12, minus 4, then what are its direction cosines? Say here direction ratios are, say let me take A is minus 18, B is 12, C is minus 4. These are direction ratios. Now to find direction cosines, let me find value of square root of a square plus b square plus c square. So square root of a square plus b square plus c square is square root of minus 18 square plus 12 square plus minus 4 square. So minus 18 square, that is square root of 324 plus this is 144 plus 16. So that is square root of 6 plus 4 10, 10 plus 4 14, keep here 4, then 1 plus 1 2, 2 plus 4 6, 6 plus 2 8, then 1 plus 3 4, 484. So this is 22. 22 square is 484. Now dividing these numbers by square root of a square plus b square plus c square, we can get direction cosines, and we have two sets of direction cosines. So direction cosines are, say plus minus a upon root a square plus b square plus c square, this was the formula, comma plus minus b upon root a square plus b square plus c square, comma plus minus c upon root a square plus b square plus c square. Every line has two sets of direction cosines. Here also we can find two sets of direction cosines. If I change sign of these three numbers, then say 0, then if you change here 1 by root 2, if you change here minus 1 by root 2. So changing sign of these numbers, we have second set of direction cosines. So second set of direction cosines are 0, 1 by root 2, minus 1 by root 2. So this is second set, this is first set. So similarly here we take plus minus. Now putting these values, that means first of all we consider plus sign. So say plus a, that is minus 18, then plus b, that is here I keep 12, then plus c, that is I keep minus 4. So it is ABC. Now I take minus a, minus b, minus c. So minus, that is change this sign. So here plus, this was plus, then minus, minus, then plus. So putting value of ABC in both the possible forms for direction cosines, putting in this formula, these are values of numerator divided by 22. Here dividing by 22. So this is equal to minus plus 18 by 22, that is 9 by 11. 9 by 11 comma plus minus 6 by 11 comma minus plus 2 by 11. So these are two sets of direction cosines. Now in this question, find the direction cosines of a line which make equal angles with the coordinate axis. We suppose that angles alpha, alpha and alpha, equal angles with axis, with x-axis, with y-axis, with z-axis, equal angle alpha, alpha and alpha. So direction cosines are L is cos alpha, M is also cos alpha, N is also cos alpha. These are direction cosines. Now we know that L square plus M square plus N square is 1. So putting these values, L square plus M square plus N square, that is 3 times cos square alpha is 1. So cos square alpha is 1 by 3. So cos alpha is plus minus 1 by root 3. So direction cosines are, therefore direction cosines are plus minus 1 by root 3 comma plus minus 1 by root 3 comma plus minus 1 by root 3. So remember, if any line makes equal angles with axis, then their direction cosines are plus minus 1 by root 3 plus minus 1 by root 3 plus minus 1 by root 3. Find the direction cosines of the sides of the triangle whose vertices are given. Let me take these as vertices. We say them, this point is A, 3, 5, minus 4, B is minus 1, 1, 2, C is minus 5, minus 2. We want a direction cosines of sides. So see, first of all, we find for line segment AB. So say direction ratios of line segment AB. This is side. Direction ratios of this side AB are, say, two distinct points are given. So direction ratios are minus 1, minus 3, minus 1, minus 3, comma 1, minus 5, comma 2, minus 4, that is 2 plus 4, x2 minus x1, y2 minus y1, z2 minus z1. Or you can also take x1 minus x2, y1 minus y2, z1 minus z2. This order can be reversed. So that is, it is equal to minus 4 comma minus 4 comma 6. Now length of this EB. So EB is square root of x2 minus x1 square, y2 minus y1 square, z2 minus z1 square. That means minus 1 minus 3 square, that is minus 4 square plus minus 4 square plus 6 square. See, these are direction ratios. So it is sum of square of these direction ratios. So it is equal to square root of 16 plus 16 plus 36. So that is it is equal to 6 plus 6 12, 12 plus 6 18, 3 plus 1 4, 4 plus 1 5, 5 plus 1 6, root 68. So here this is divisible by 4, so this can be written as square root of, it is 4 into 17 into 4, so 2 root 17, this is 2 root 17. So direction ratio of AB are this number, and now we are dividing these numbers by this 2 root 17, that will be direction cosines of AB. So direction cosines of AB, direction cosines of side AB are minus 4 by 2 root 17, minus 4 by 2 root 17, comma, minus 4 by 2 root 17, comma, 6 by 2 root 17. That is minus 2 by root 17, comma, minus 2 by root 17, comma, 3 by root 17. So these are direction cosines of line segment EB. So this was about this first side. Now we do similarly for second side, BC. So direction ratios of BC, direction ratios of BC, it is equal to, say this is BC. So again x2 minus x1, so minus 5 minus minus 1, that is plus 1, comma, minus 5 minus 1, comma, minus 2 minus 2, that is, so x2 minus x1, y2 minus y1, z2 minus z1, so it is minus 4, comma, minus 6 minus 4. Now we find length of BC. So BC is equal to square root of minus 4 square plus minus 6 square plus minus 4 square. So what is it? It is nothing but by distance formula, x2 minus x1 square plus y2 minus y1 square plus z2 minus z1 square, and already here we have calculated x2 minus x1, y2 minus y1, z2 minus z1. So we are using these final values in this distance formula. So it is equal to square root of 16 plus 36 plus 16. So again it is same numbers, root 68, 16, 16, 36, root 68, so 2 root 17. Now we divide these direction ratios by its a sum of square root of sum of squares of these numbers. So we divide this by this distance BC. So direction cosines of BC are minus 4 by 2 root 17, comma, minus 6 by 2 root 17, comma, minus 4 by 2 root 17, that is minus 2 by root 17, comma, minus 3 by root 17, comma, minus 2 by root 17. Then third side, about AC or you can say CA. So direction ratios of AC, direction ratios of AC are x2 minus x1 minus 5, say x2 minus x1, y2 minus y1, z2 minus z1. So minus 5 minus 3, minus 5 minus 3, comma, minus 5 minus 5, comma, minus 2 plus 4. So that is minus 8 minus 10 plus 2. Then distance AC is square root of minus 8 square plus minus 10 square plus 2 square. That is square root of 64 plus 100 plus 4. That is square root of 168. So that is distance AC. Now let me check, is it divisible by 2 or 4? Divisible by 4. So again it is divisible by 4. So it is 4 into 42. So it is 2 root 42. So therefore direction cosines of AC are, dividing these numbers by distance AC, so it is minus 8 by 2 root 42, comma, minus 10 by 2 root 42, comma, 2 by 2 root 42. That is minus 4 by root 42, comma, minus 5 by root 42, comma, 1 by root 42. So these are direction cosines of AC. Now see, in this calculation, if we change order of this subtraction, instead of x2 minus x1, y2 minus y1, z2 minus z1, if I take x1 minus x2, y1 minus y2, z1 minus z2, then this sign will be changed. So sign of these numbers will be changed, and we know that every line has two sets of direction cosines. So in this question we can also show both sets of direction cosines. So see, for line segment AB, direction cosines are minus plus minus plus plus minus. Here direction cosines are minus plus minus plus minus plus. Here minus plus minus plus plus minus. So in this calculation, here I keep in note form. In calculation, changing sign of direction cosines, we can have second set of direction cosines. We can find second set of direction cosines. That is, for AB, direction cosines of AB, that is 2 by root 17, comma, 2 by root 17, comma, minus 3 by root 17. Direction cosines of BC, direction cosines of BC, change the sign, 2 by root 17, 3 by root 17, 2 by root 17. And direction cosines of AC, line segment AC or line AC, 4 by root 42, comma, 5 by root 42 comma minus 1 by root 42. Every line has two sets of direction cosines.